A space laser system blasts into orbit. Up, up and away, a Russian Proton rocket carrying the Eutelsat 9B satellite lifts off from the Baikonur Cosmodrome. It's destined to send hundreds of TV channels to European homes, but it has something much more interesting on board. The first node of a laser communication system called the European Data Relay System, or EDRS. EDRS hopes to solve a problem that currently affects satellites in low Earth orbit. This is about 400 to 600 kilometers above the Earth. That's much closer than the 36,000 kilometers of TV and telecom satellites like Eutelsat 9B. The satellites are flying low to the ground because they're taking pictures or collecting scientific data, but that low orbit means they're often out of range of a ground station that can receive their signals. In a typical 90-minute orbit, they might only be able to transmit data for 10 minutes, so delays occur. Because Eutelsat 9B is much higher, it can keep contact with the low Earth orbit satellite for much more of its orbit, and that's where EDRS comes in. The two satellites link via laser that can carry data at up to 1.8 gigabits per second, much faster than any comparable radio system could manage. And because Eutelsat 9B is up in geostationary orbit, it appears in the same space in the sky all the time, so it's always in contact with a ground station. The setup means much less delay in getting data back to scientists and emergency services. The system will get its first proper test later this summer, when the Copernicus Sentinel-1 and 2 satellites are launched. EDRS can handle up to 50 terabytes of data per day, speeding the transmission of important satellite data. If it all works, the European Space Agency plans to launch a dedicated EDRS satellite in 2017 and move towards a global system from 2020.